Hey team, I'm Brains, I'm your math tutor, and today we're going to do inverse trig functions part 2. If you haven't seen part 1, you should pause the video and take a look, otherwise you're going to have a bad time. This video is just going to be 5 more problems about solving and simplifying some inverse trig functions. So grab your reference sheets and let's go! Okay guys, so you ready? It's problem 1. Okay, so we've got the sine of sine inverse of 1/5 plus cosine inverse of x all equal to 1. Okay, well, let's take a look here. So we know from basic trig from before that sine of pi over 2 is 1. All right, so that means that this inside piece is equal to pi over 2. All right, so let's rewrite it. So then we have sine inverse of 1/5 plus cosine inverse of x is equal to pi over 2. Well, let's take a look here. We know that from our inverse trig identities, we have the sine inverse of x plus the cosine inverse of x equals to pi over 2. So that means sine inverse of x is equal to pi over 2 minus cosine inverse. Right? Okay. We're going to use that with our main function. We've got sine inverse of 1/5. We're going to bring this cosine inverse of x over to the one side. We've got sine inverse of 1/5 is equal to pi over 2 minus cosine inverse of x. Well, look at that. We know that that is sine inverse of x. So we've got sine inverse of 1/5 is equal to sine inverse of x. Well, if we take the sine of both sides, they cancel out. So we've got 1/5 is equal to x. There you go. X is equal to 1/5. Done like dinner. Next problem. All right, problem 2. We got to simplify this tan inverse of all this garbly-gook. Okay, we've got the square root of 1 minus cosine x over 1 plus cosine x. Oh, okay. Well, let's work with them separately. So 1 minus cosine x. We know from basic trig identities that cosine of twice an angle is equal to 1 minus 2 sine squared of that angle. Okay. Well, let's change this. Let's change theta to be x over 2. Okay. So if theta is x over 2, so we're just going to replace this. So we've got cosine of 2x over 2 is equal to 1 minus 2 sine squared of x over 2. Okay, well, this 2 and this 2 cancels out. So we'll have just cosine of x is equal to 1 minus 2 sine squared x over 2. Okay, interesting. Let's rearrange a little bit. Let's bring this 2 sine squared over to the other side and the cos x to the other side. We've got 2 sine squared x over 2 is equal to 1 minus cos x. All right, that's a good start. Let's look at the other one now. Okay, we've got 1 plus cos x. Remember from our trig identities that cosine of twice an angle is equal to 2 cosine squared theta minus 1. Now, we're just going to replace theta with x over 2. Okay, so that's going to give us cosine of 2 times x over 2 equals 2 cosine squared of x over 2 minus 1. Oh, these 2's cancel out. We got cosine of x is equal to 2 cosine squared of x over 2 minus 1. We'll bring the 1 to the other side. We've got a 1 plus cosine of x is equal to 2 cosine squared of x over 2. Okay. Now we can replace our 1 minus cosine x and 1 plus cosine x with a couple values. Let's do this. Okay, so remember we had tan inverse of the square root of 1 minus cosine x over 1 plus cosine x. This is going to become tan inverse of the square root. 1 minus cosine x is 2 sine squared of x over 2. So 2 sine squared of x over 2. And 1 plus cosine x is 2 cosine squared of x over 2. Oh ho ho, look at this. Those 2's cancel out. Oh, this is even better. We've got tan inverse of the square root. Oh look, sine squared over cos squared. That's tan squared. We've got tan squared of x over 2. Ooh, this is going to be equal to tan inverse of tan. Oh no, look at this, x over 2. Tan inverse of tan cancels out, so we just get x over 2, and we're done. Okay, problem 3. We need to write in simplest form the tan inverse of 1 over the square root of x squared minus 1. Okay, let's do this. First things first, we're going to play a little trick here, and we're going to let x equal secant of theta. Okay, interesting here. That means this tan inverse of 1 over the x squared blah 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 is going to be tan inverse of 1 over the square root of secant squared theta minus 1. Okay, remember trig identities? That 1 plus tan squared theta is secant squared theta. So that means that secant squared theta minus 1 is tan squared. All right, let's use it and keep going. So that means that this is going to be the tan inverse of 1 over the square root. Well, secant squared minus 1 is tan squared. So this becomes then the tan inverse of 1 over square root of tan squared is just tan. So tan. Well, 1 over tan is cotan. We've got tan inverse of cotan of theta. Okay, well, we got another little identity that tan of pi over 2 minus theta is cotan. All right, so that means on the inside here, we've got tan inverse of tan of pi over 2 minus theta, which means the tan inverse and tan cancel each other out. So we've got this equals to pi over 2 minus theta. Remember that we let x equal secant theta. So that means theta would be secant inverse of x. That means that pi over 2 minus secant inverse of x. All right. Okay, let's go. All right, problem 4. We've got another one where we have to write it in simplest form. Again, we're going to use a little trick here, but we're going to let x equal a sine theta. All right, let's do this. That means this is going to turn into tan inverse of a sine theta over the square root of a squared minus, well, now x squared is a squared sine squared theta. All right. That's going to become tan inverse of, well, a sine theta stays the same. But we can factor out this a squared on the bottom. So I'm going to write it twice. We've got a squared, 1 minus sine squared. What's 1 minus sine squared? Well, from our trig identities on our reference sheet, it is co-squared. So that means that we have tan inverse of a sine theta over the square root of a squared co-squared theta. We could take the square root of the squares. We've got tan inverse of a sine theta over a cos theta. That means we've got tan inverse. Well, the a's cancel out, so we've just got tan theta, which just gives us theta. X equals a sine theta, which means, okay, let's rewrite this. That means we'll divide by a, so x over a equals sine theta, which implies that theta equals sine inverse of x over a, which means our question simplifies to the sine inverse of x over a. Okay, last problem. I'm gonna let you try this one. So you can go ahead and pause the video and give it a try. I'm gonna give you a hint though. Let's let x equal to cosine of 2 theta. Okay, give it a try. I'm sure you got it, so let's give it a shot. Let's do tan inverse. Oh, this is a big one. 1 plus x. Well, the square root of 1 plus cosine of 2 theta minus the square root of 1 minus cosine of 2 theta all over, well, the square root of 1 plus cosine of 2 theta plus the square root of 1 minus cosine of 2 theta. Oof. Again, we're going to use some trig identities and simplify this a little bit. Remember that cosine of 2 theta is equal to 2 cosine squared theta minus 1, and cosine of 2 theta is equal to 1 minus 2 sine squared theta. All right? That means that 1 plus cosine 2 theta is equal to 2 cosine squared theta, and 1 minus cosine 2 theta is equal to 2 sine squared theta. Okay, let's plug them in. Okay, so we know what these are. So tan inverse of 1 plus cosine 2 theta is the square root of 2 cosine squared theta minus the minus 1. So this is going to be the square root of 2 sine squared theta all over 1 plus cosine 2 theta turns into 2 cosine squared theta, then a plus, then a square root, then a 2 sine squared theta. Oh yeah, it's so fun. Okay, so we got tan inverse, and well, these all can simplify a little bit. We can have a square root of 2 cosine theta minus the square root of 2 sine theta, and then this is going to be divided by the square root of 2 cosine theta plus the square root of 2 sine theta. Well, we can take out a square root of 2 on the top and bottom, so they'll cancel out. So we've got tan inverse. Well, I'm going to just show it anyways. Square root of 2 cosine theta minus sine theta over the square root of 2 times cosine theta plus sine theta. Square root of 2's cancel out. Okay, well, what are we going to do now? Here's a trick. We're going to make this somehow in terms of another tan trig identity. Just watch. We've got the tan inverse of, I'm going to divide both the top and bottom by cosine theta. Okay? If I go cosine theta minus sine theta divided by cosine theta all over cosine theta plus sine theta divided by cosine theta, that's going to turn into the tan inverse of cosine divided by cosine is 1, so 1 minus sine divided by cosine is tan, 1 minus tan, all over cosine divided by cosine is 1, so 1 plus sine divided by cosine is tan. All right, not bad. Here's another little thing we need to know. Well, 1 is actually the tan of pi over 4. If you look at the unit circle, tan of pi over 4 is 1. Do a little replacement here. We're going to have the tan inverse. Instead of the 1 on the top, we're going to say it's tan of pi over 4. So tan of pi over 4 minus tan theta. We're not going to replace the 1 on the bottom. We're just going to remember that 1 times anything is that anything. So there's an invisible 1 here on this tan. So we're going to replace that. So this will be 1 plus tan of pi over 4 times the tan of theta. Okay, now this looks a little bit familiar. Remember that tan of x minus y is equal to tan x minus tan y over 1 plus tan x tan y from our reference sheet, our trig identities. That means this inside can turn into tan inverse of tan of pi over 4, because that would be our x, minus theta. Well, take a look. Tan inverse of tan, this just gives us pi over 4 minus theta. What was theta? Remember, we let x equals the cosine of 2 theta, which means we take the inverse, so we've got cosine inverse of x equals 2 theta, which then becomes theta is equal to cosine inverse of x over 2, which means our answer is pi over 4 minus cosine inverse of x over 2. Done like dinner. Actually, I don't have any dinner, so and that's all I got. Thanks for watching today's video. If you have any questions or anything, just let me know in the comments down below. And if you want to take a look at my printable pages, go ahead and check out my Discord. Link in the description. Don't forget to hit that like and subscribe button, and I'll catch you in the next one. See ya!